Where would you arrive if you kept traveling straight through the cosmos, never stopping, never turning back? Would you reach a boundary, or would the universe simply unfold forever ahead of you? Welcome back, traveler. Tonight, we drift through science. Picture a dark ocean without waves, without wind, without shorelines. Imagine yourself gliding across this stillness, surrounded by tiny flecks of light that shimmer like frost suspended in air. The further you move, the more the horizon retreats, stretching outward as though the universe is quietly stepping away, inviting you deeper while refusing to reveal where it ends. Night settles around you now, soft and steady, as if the world has been gently dimmed just for this moment. The pace of your thoughts begins to slow, matching the calmness of the sky. You're wrapped in the quiet comfort of a universe too vast to measure, yet somehow intimate enough to rest inside. Whatever weight you carried today dissolves a little, replaced by a silence that feels both ancient and kind. The question of whether space ends touches more than physics. It brushes against our longing to understand the structure that holds us. Scientists explore shapes of spacetime, cosmic expansion, and the geometry of the cosmos not out of mere curiosity, but because these mysteries reveal how reality is woven. To wonder about edges is to wonder about our place within a tapestry far larger than any map we could draw. If these gentle wanderings bring you peace, I'm grateful you're here with me tonight. A quiet gesture, a like, a subscribe, a moment of support, helps keep this little corner of calm science glowing softly for others who might need it too. Only do so if it feels natural. This space exists to soothe, not to demand. So let your mind drift a little farther from the noise of the day. Let the stillness expand like a slow breath. Somewhere ahead, a deeper question waits, not about how far space stretches, but what it means for something to have no end at all. The question of whether space ends becomes more intriguing the moment you consider how it behaves. Space isn't static, it stretches, expands, and evolves. What appears calm and still from Earth is actually in motion, carrying galaxies away from each other at astonishing speeds. That motion hints at something deeper, that maybe the universe isn't merely big, but actively growing, reshaping the boundaries we try to define. As telescopes observe distant galaxies, their light carries the imprint of expansion. The farther away a galaxy is, the faster it appears to be receding. This relationship, known as cosmic redshift, was one of the earliest clues that space itself is stretching. Not objects moving through emptiness, but emptiness increasing between objects. It's like watching dots on a balloon grow farther apart as the balloon inflates. Imagine holding that balloon in your hands. As it grows, no single dot rests at the center. Every dot sees every other dot drifting away. Scale that to cosmic proportions, and you begin to understand. Expansion doesn't push galaxies outward. It expands around them, beneath them, between them. This leads to a quiet realization. If space keeps stretching, then the idea of an edge becomes harder to imagine. When you trace the history of the universe backward, everything converges. Galaxies once crowded closer, stars lived in younger clusters, and matter condensed into regions more compact than anything we see today. That shrinking horizon eventually reaches a point so dense, so uniform, that our familiar notions of space and boundary lose meaning. The Big Bang wasn't an explosion into pre-existing emptiness. It was the moment when space itself began expanding, carrying energy and matter with it. There was no outside, no external container. The universe wasn't placed somewhere. It generated its own somewhere as it grew. That idea alone reshapes the way you visualize beginnings. Think of a book that writes its own pages as the story unfolds. No front cover, no back cover, just a narrative that expands its world with every new sentence. You start to see why asking where space ends is similar to asking where a horizon ends. Even today, as we map galaxies, we notice patterns that reveal large-scale structure, filaments, clusters, and vast voids stretching for hundreds of millions of light years. These structures form a cosmic web with no clearly defined perimeter. Instead of edges, we find transitions, dense regions gradually thinning into emptier stretches. Astronomers study this distribution using surveys like SDSS and DESI, which chart the positions of millions of galaxies. Their maps reveal that matter isn't scattered randomly. It forms networks shaped by gravity, dark matter, and the early ripples left in the cosmic microwave background. Yet nowhere in these maps appears a boundary, a wall, a stopping point. Visualize this cosmic web like roots beneath an ancient forest. The roots extend, branch, twist, and fade, but no single root marks the end of the forest. From this perspective, infinity becomes less intimidating and more like a natural continuation. As observations improve, we detect fainter galaxies at the limits of visibility. JWST reveals structures so distant that their light began traveling long before the Milky Way formed. Each new discovery pushes the edge of the observable universe farther, like uncovering new islands beyond a misty sea. But even this vast sphere, 46 billion light-years in radius, doesn't mark the full extent of space. It simply shows how far light has reached us. Beyond that sphere, the universe continues, indifferent to our ability to detect it. We live inside a bubble defined not by walls, but by time. Picture standing inside a lantern at night. The warm glow defines the world you can see, while beyond that glow lies a darkness that may hold endless landscape. And so the question shifts from, does space end, to what lies beyond what we can ever witness? The expansion of space affects more than distance, it affects possibility. Regions of the universe recede faster than light can travel, pulled away by expansion so quickly that their light will never reach us. These regions are not gone, they are simply inaccessible. In an expanding universe, boundaries are created not by walls, but by the limits of communication. Cosmologists call this the cosmic event horizon. Anything beyond it can never influence us. Not now, not ever. Even if civilization lasted for trillions of years, those distant galaxies would remain silent ghosts, unreachable and invisible. Think of rowing across a lake shrouded in morning fog. You know the water continues beyond the mist, but no effort lets you see past it. The universe hides its farthest stretches not out of secrecy, but because distance and time collaborate to veil them. Another layer of wonder comes from how space might be shaped. When thinking about endings, most people imagine a flat expanse, but the universe could curve. It might wrap subtly or dramatically. It might even loop in ways that would allow you to travel straight ahead and eventually return to where you began, without ever encountering a boundary. Mathematically, this is called a closed but unbounded universe, finite in volume yet lacking edges. It's similar to walking on the surface of a sphere. You can keep moving indefinitely, but you will never fall off or find a wall. The experience feels infinite while being structurally constrained. Imagine a tiny figure strolling across a globe, unaware of its shape, yet experiencing endless forward motion. Curvature is one of the keys to unlocking whether space ends or not. Measurements from missions like WMAP and Planck suggest the universe is extremely close to flat. But flat in cosmology doesn't mean empty or two-dimensional. It means the geometry aligns with Euclidean rules at large scales. Yet the margin of error in these measurements still leaves room for slight curvature, subtle enough that we wouldn't detect it within the observable region. In a nearly flat universe, space can still be finite or infinite. The distinction hides beyond the horizon. This ambiguity means the cosmos could stretch forever or bend gently into a shape larger than our cosmic bubble can reveal. Imagine staring at the horizon of an ocean, flat as far as you can see, yet undeniably curved from above. This uncertainty is not a flaw in science, it's a reminder of scale. And so, as you drift through the question of whether space ends, you realize we're suspended between what can be measured and what must be imagined. The tools we build extend our reach, but the universe extends faster. Every answer leads to another layer of mystery, not because we're failing, but because reality is richer than our senses were built to perceive. That realization carries a soft sort of wonder, the feeling that instead of reaching the limit of knowledge, you've stepped into a realm where curiosity becomes a companion rather than a problem to solve. It's like walking through a dimly lit hall, each door opening into another, each room larger than the last. And with each step, you sense that the edges you thought existed were simply moments of pause before the next horizon. Space becomes even more astonishing once you consider that everything we see, every star, every cluster, every faint thread of the cosmic web, represents only the tiniest sliver of what exists. The visible universe is like a lantern glowing in a vast night, illuminating only a small region around us. Beyond that glow lies a darkness that may stretch outward without interruption, carrying truths we'll never witness. When astronomers measure the cosmic microwave background, they're effectively listening to the oldest whisper the universe has preserved. That faint radiation, spread evenly across the sky, contains tiny fluctuations, variations in temperature no larger than a few millionths of a degree. These ripples reveal the early scaffolding of galaxies and hint at the overall geometry of space. They act like a fossilized map, drawn long before stars took shape. Those faint variations resemble the soft texture of sand dunes when viewed from far above, gentle rises and dips that hide the forces shaping them. And so, the universe begins to feel less like emptiness and more like a memory etched into light. Distances on cosmic scales behave strangely compared to everyday intuition. A galaxy may appear frozen, suspended in a patch of blackness, when in reality it's racing away from us faster than any rocket could chase. The farther away something is, the faster space stretches between us and it. This effect becomes dramatic at extreme distances, making the idea of an edge increasingly blurry. Observations show that galaxies beyond a certain threshold recede faster than light due to expansion. This doesn't violate relativity, because the galaxies themselves aren't moving through space that quickly. Instead, space itself is amplifying the separation. It's a subtle distinction, but one that changes how we think about boundaries. Expansion creates distance faster than travel can close it. Picture two boats drifting on a still lake while the water between them gently flows apart. The vessels themselves remain still, yet the gap widens effortlessly. From that widening gap arises the possibility that distance is not a limit, but a feature of cosmic design. Another astonishing idea emerges when considering how light behaves over long distances. Photons traveling for billions of years stretch into longer wavelengths because the fabric of space-time elongates beneath them. Light that began as brilliant blue may arrive as dim red, its energy reduced by expansion. This means the universe hides its oldest regions behind a veil of stretched, faded light. JWST has allowed us to pierce deeper into this veil, capturing galaxies from an era only a few 100 million years after the Big Bang. These young galaxies appear small, irregular, and intensely bright, revealing the turbulent early growth of the cosmos. Yet even with this extraordinary reach, we still glimpse only the first chapters. Their distant forms seem like lanterns glimpsed through fog, present, glowing, but altered by the long journey. Moments like this remind you how fragile our window into the universe really is. The idea of an infinite universe isn't the only possibility. Some theories propose a cosmos that curves back on itself, not as a sphere in three-dimensional space, but in a more abstract, higher dimensional way. Such a structure would be finite yet unbounded, a place where direction exists, but destination loops back subtly. You could travel eternally without ever finding a wall. Einstein's general relativity doesn't dictate the universe's shape. It only describes how matter and energy influence curvature. To determine the large-scale geometry, scientists measure how light from distant galaxies bends, stretches, and distorts. So far, the data suggest a universe incredibly close to flat, but the measurement's precision allows room for a slight curvature, too subtle for our current tools to confirm. Think of running a fingertip across a giant globe so smooth that it feels flat. Only distance reveals its shape. This uncertainty is not a flaw. It's a testament to the scale we're dealing with. Galaxies themselves reveal secrets about the universe's possible infinity. Their distribution follows patterns shaped by dark matter, gravity, and early quantum fluctuations. These patterns extend far beyond what we can map fully. No matter how far surveys reach, the web-like structure continues, fading gradually but never truly ending within observable limits. Projects like Euclid and LSST aim to chart billions of galaxies to understand these patterns. Their data could reveal clues about whether the universe repeats structure or transitions into something different at extreme distances. For now, the cosmic web appears continuous. Not random, not chaotic, but woven with a coherence that spans unfathomable scales. The sight of that endless structure evokes the image of city lights seen from an airplane at night. Clusters, threads, glimmers stretching beyond the horizon. And with that thought comes the realization that cosmic architecture isn't bound by human intuition. Another point to consider is that infinite space comes with profound consequences for probability. If the universe stretches without end, then regions may exist where matter arranges itself in familiar ways simply because every possible configuration occurs somewhere. This doesn't suggest duplicates in a literal sense, but it challenges our sense of uniqueness. Cosmologists studying inflation propose that rapid early expansion could produce patches of space that extend far beyond our observable bubble. Each patch could contain variations in density, temperature, or even physical constants, creating a mosaic of cosmic neighborhoods. Some patches may resemble our own, others may be wildly different. This patchwork resembles clusters of islands formed by volcanic activity, each with its own landscape shaped by the same deep forces. Such ideas stretch the imagination, yet remain grounded in physics, not fantasy. Ultimately, what we call the edge of the universe may be less about distance and more about what we can meaningfully interact with. Horizons imposed by expansion define the limits of influence. Beyond them lie regions permanently separated from us. They are real but forever inaccessible. As time moves forward, these horizons shift. Some regions that were once visible slip beyond reach. Future astronomers will see a dimmer sky with fewer galaxies, not because galaxies vanish, but because expansion outpaces the arrival of their light. The universe gradually reveals less, even as it contains more. In a way, the cosmos behaves like a tide, rising, pulling distant shores away from view, leaving us with a shrinking field of vision. And in that ebbing tide, you sense the quiet truth that vastness does not guarantee visibility. One of the most striking realizations about space is that its behavior at the largest scales doesn't mirror anything we encounter in daily life. On Earth, distances are fixed. A road stays the same length whether you walk it today or tomorrow. But in the cosmos, distance itself is a moving target. The space between galaxy clusters stretches subtly at first, then dramatically across billions of years, reshaping the vast architecture of the universe. Researchers measure this shifting tapestry using type Ia supernovae, exploding stars that shine with predictable brightness. Because their luminosity is well understood, scientists can infer distance from how dim they appear. Surprisingly, these supernovae revealed that distant galaxies were farther away than expected, indicating the universe's expansion is accelerating. This discovery reshaped modern cosmology and led to the concept of dark energy. Their faint glow feels almost like a lighthouse beam seen from a lonely coastline, steady, distant, and speaking across unimaginable separation. That faintness hints not at weakness, but at the scale of the ocean they illuminate. If the universe accelerates as it expands, then the idea of an edge takes on new dimensions. Instead of a physical boundary, we encounter a consequence of speed. Distant regions slip beyond the ability of light to connect with us. This creates a kind of curtain, not a barrier, but a limit to communication imposed by time and expansion. Some cosmologists refer to this curtain as an event horizon. Though unlike a black hole's boundary, it doesn't trap anything. It simply defines which parts of the universe can ever exchange signals. Anything beyond this horizon drifts into permanent solitude relative to us. Not gone, not erased, just forever unreachable, like a ship sailing beyond the curvature of the Earth. The image resembles watching lanterns float down a river at dusk, drifting into darkness where no eye can follow. Such separation carries a strange beauty. Distance becomes a kind of gentle silence. Another layer of wonder comes from the earliest moments of cosmic history. Inflation, a period of extremely rapid expansion, likely stretched the universe far beyond what we can observe. During that instant, space ballooned faster than the speed of light, smoothing out irregularities and spreading tiny quantum fluctuations across enormous scales. Those fluctuations seeded everything that exists today. Measurements of the cosmic microwave background reveal these ancient imprints. Tiny temperature variations correspond to sound waves that rippled through the primordial plasma before atoms formed. These patterns match predictions of inflation remarkably well, suggesting the universe once grew so quickly that any possible boundary was pushed far beyond our visible horizon. Those sound waves evoke the image of ripples spreading across a vast, glowing lake in the first moments of dawn. And in that image is the sense that beginnings shape everything long after they fade. While inflation pushes the idea of an edge far out of reach, another question emerges. Could the universe be part of something larger? Some theoretical models propose that our cosmos might be one bubble in an enormous multiversal landscape. If this is true, each bubble could have its own physical laws, constants, and dimensions. Boundaries might exist, but as transitions between domains rather than limits of space itself. These models arise from theories in high-energy physics, particularly those exploring vacuum states and potential energy levels. If the universe rests in a metastable state, neighboring regions might occupy different ones, creating a cosmic mosaic. Interaction between these regions would be rare, perhaps impossible, depending on the energy barriers that separate them. The idea resembles countless soap bubbles clustered together, each delicate, round, separate, yet born from the same underlying film. Such speculation invites humility, reminding us how little of reality we may actually perceive. Even without multiple universes, dimensionality itself could alter our sense of endings. Some theories suggest that space might have more dimensions than the ones we experience. If extra dimensions are compactified, curled tightly at scales impossible to detect, then the universe could be vast in ways that defy human geometry. An edge might exist in a dimension we cannot access, hidden from every form of measurement. String theory proposes such hidden dimensions, with gravity potentially leaking into them. Attempts to detect deviations in gravitational behavior at small scales continue, but so far, the findings align with familiar physics. Still, the possibility remains intriguing. our cosmos might be embedded in a structure richer than our senses can reveal. This concept feels like reading a story printed on a single sheet, while knowing the full tale is woven through volumes stacked just beyond reach. Mystery doesn't diminish truth, it widens the path toward understanding. One of the most elegant ideas in modern cosmology comes from how light travels through curved space. If the universe bends, then beams of light follow those curves. A sufficiently curved universe might allow light to eventually loop around, offering the possibility that distant regions of the sky are actually mirror views of the same objects from different angles. Efforts to detect such patterns include searching for repeating circles in the cosmic microwave background. If light wrapped around the cosmos, identical temperature patterns would appear in multiple regions of the sky. So far, no such repetition has been confirmed, suggesting that if curvature exists, its scale exceeds the observable universe. The cosmos may be curved, but on a radius so large that our instruments cannot detect the bend. The idea recalls walking a near-infinite plane. Even if the ground curves subtly, it feels flat beneath your feet. Sometimes the absence of evidence simply reflects the enormity of the landscape. Another clue comes from galaxy distribution. Surveys reveal that matter forms a sprawling network, filaments branching across unfathomable distances, clusters gleaming like knots of starlight, voids yawning empty in between. This structure repeats on various scales but eventually begins to smooth out. Beyond a certain threshold, patterns fade into uniformity, suggesting no inherent direction or boundary. This large-scale homogeneity supports the cosmological principle. The idea that the universe looks statistically the same in every direction when viewed from a sufficiently large vantage point. Though not perfect, this principle holds remarkably well. It implies that no special edge encircles the universe. Instead, structure gradually transitions to simplicity at vast scales. Galactic maps resemble a city viewed from high above at night, intricate up close, but blending into a glow of lights as distance increases. Such uniformity gestures toward an infinite canvas, or at least one far larger than our horizons allow. Among the most surprising implications of all this is the possibility that the question, "Does space end?" might have no single answer. Space could be infinite yet inaccessible, finite yet unbounded, expanding yet revealing less over time. Boundaries may exist, but not in the way a wall or cliff marks an end. Instead, they might take the form of limits to knowledge, communication, or measurement. Physics often teaches us that a thing can be true in unfamiliar ways. Space can be endless without being infinite, finite without walls, boundless without boundaries. Understanding emerges not from simplification, but from accepting that reality can hold contradictory qualities simultaneously. It's similar to watching the sky at twilight, neither fully day nor fully night, yet entirely itself. From this ambiguity arises the sense that the cosmos is richer than any single explanation could express. Some of the most revealing clues about whether space ends come not from distance, but from the way gravity sculpts the universe. Gravity isn't merely a force pulling objects together. It shapes the very stage they move upon. The curvature of space-time adjusts itself in response to mass and energy, as if the universe were constantly reshaping its own terrain to accommodate every star, every cluster, every dark corner. Researchers map this curvature by studying how galaxies distort the light passing near them. This phenomenon, gravitational lensing, creates arcs and stretches in distant images, letting us infer the invisible structure beneath. Strong lensing reveals dense clusters. Weak lensing uncovers subtle gradients spread across enormous scales. Together, they form a portrait of a universe without visible walls. The effect resembles ripples forming around stones beneath a still pond, unseen objects quietly altering the surface above. Such distortions suggest a cosmos that bends rather than breaks. The farther you look, the more pronounced the bending becomes. Entire clusters of galaxies act as cosmic magnifying glasses, warping light from background galaxies stretched across billions of light years. These distortions allow astronomers to weigh structures they cannot see directly, including dark matter halos that envelop galaxies like vast, invisible cocoons. These halos reveal that most of the universe's mass doesn't shine. It interacts gravitationally but not through light, forming frameworks that guide the formation of galaxies. This scaffolding extends far beyond any region we can observe. Wherever our measurements reach, dark matter continues, shaping the distribution of structures on ever larger scales. The pattern evokes the idea of roots tunneling through soil, hidden, connecting everything, shaping what grows above. What lies beyond those roots remains unseen, but their influence expands without pause. Another key to this puzzle appears when considering how galaxies move relative to one another. While expansion stretches space, gravity tugs locally, binding clusters and superclusters into immense formations. The balance between these opposing influences determines the universe's long-term fate. If expansion wins decisively, galaxies drift apart indefinitely. If gravity dominates, collapse might occur on unimaginable timescales. Current measurements show that expansion is accelerating, suggesting that galaxies far from our local group will eventually slip beyond detectability. Yet, within gravitationally bound regions, motion continues subtly, like dancers adjusting to shifting rhythms. These small movements reveal deeper structure and offer insight into whether the cosmos might possess large-scale boundaries. The dance is reminiscent of fireflies circling one another in a dark field, each guided by unseen cues, never colliding yet never entirely free. Even at cosmic scales, motion carries quiet meaning. Another intriguing idea emerges from observing how large voids form. These vast regions contain far fewer galaxies than average, stretching across hundreds of millions of light years. Voids aren't empty. They simply lack the density needed to ignite star formation. Their presence creates contrast within the cosmic web, highlighting the filaments and clusters that form the universe's luminous skeleton. Mapping these voids reveals patterns strikingly consistent across different regions of the sky. No matter where astronomers search, the interplay between dense and sparse volumes follows similar rules. This uniformity suggests that the universe doesn't thin out toward a boundary. Instead, it maintains structure at every scale we can reach, repeating its geometry without pointing toward an edge. The image resembles lace spread across a table, intricate yet evenly patterned, full of openings that enhance its beauty. That consistency hints at a cosmos guided by principles that extend far beyond the visible horizon. Looking deeper into the cosmic microwave background provides yet more clues. Its almost uniform temperature suggests that distant regions of space were once in close contact, even though they are now far apart. This observation supports the idea that the universe expanded from a hot, dense state so rapidly that widely separated regions share nearly identical properties. Small temperature fluctuations in that ancient light reveal density variations that later grew into galaxies and clusters. These fluctuations display a striking statistical uniformity. No direction in the sky stands out as special. If the universe had an edge or central point, these patterns would differ. Instead, the symmetry implies a cosmos without preferred boundaries. That symmetry feels like hearing the same soft tone echo evenly in every direction, balanced, calm, without a center of origin. Uniformity doesn't tell us the universe is infinite, but it suggests it behaves as if it could be. Another method used to probe cosmic extent is the Baryon acoustic oscillation scale, a kind of standard ruler imprinted in galaxy distribution. These oscillations are relics of ancient sound waves that propagated through the early universe. By measuring how galaxies cluster at certain separations, astronomers determine how expansion has changed over time. The results consistently match predictions of a universe with no obvious edge within observable limits. Expansion behaves smoothly. Structure forms predictably. No abrupt transitions appear in the data. No sharp drop-off in galaxy density. Everything fades gradually, not suddenly. The pattern is reminiscent of a coastline viewed from far above, long, winding, consistent in character, even when details vary. Subtlety often reveals more than dramatic features. Another surprising aspect of space is how it holds energy even when matter is absent. The vacuum is not truly empty. It contains fields, fluctuations, and the potential for particles to appear temporarily. This vacuum energy may be responsible for driving the universe's accelerated expansion. Its uniform presence across space suggests that the structure of reality persists endlessly, even where no stars or galaxies shine. Quantum field theory predicts that these fluctuations occur everywhere, without boundaries. Even in the darkest voids, fields hum with faint activity. If space ended abruptly, these fields would need to behave differently at the boundary, a change that would leave observable signatures. None have been detected. The idea resembles a soft vibration running through an instrument string, continuous, persistent, unaffected by distance. Such continuity hints at a cosmos with no walls to halt the resonance. Even the behavior of time intertwines with the discussion of cosmic limits. If the universe had a beginning, its age constrains how far we can observe. But it does not necessarily constrain how far space extends. Regions beyond our horizon might be vastly older or structured differently, while still being part of the same continuum. Time marks our experience, not the universe's boundaries. As time passes, the observable universe grows. More distant light reaches us, yet expansion ensures that some regions remain perpetually hidden. This interplay between visibility and invisibility blurs our sense of edges. What we can see is not the whole. What lies beyond is not absent and only delayed. The feeling mirrors standing in a valley as sunlight climbs over a mountain ridge, slowly revealing more, without altering the world beyond the ridge itself. Edges, it seems, are often artifacts of perspective rather than reality. All these clues, curvature, expansion, dark matter, ancient radiation, quantum fields, point toward a universe that behaves as though it continues far beyond our reach. Whether it ends somewhere is less important than how it unfolds where we can observe. Space reveals itself not with walls or borders, but with patterns that stretch outward smoothly. In this sense, the cosmos doesn't present itself as a room with boundaries, but as a landscape with misty horizons, always expanding, always revealing, always concealing. The question of endings becomes a poetic one, not because physics lacks answers, but because the answers depend on concepts far bigger than our lived experience. It's similar to watching the sea merge with the sky. The line between them exists only because your eyes need a place to rest. And so the exploration continues not toward an edge, but into deeper understanding of what end could possibly mean. Some questions in science carry a certain stillness around them, as though they were meant to be approached slowly. The question of whether space ends belongs to this category. The deeper you explore it, the more you sense that the universe hides aspects of itself not out of deception, but out of scale. What we call mystery is often just distance, distance so vast that even light resigns itself to silence. One of the most enigmatic clues about the universe's possible extent comes from dark energy. This invisible presence behaves almost like a pressure woven into the fabric of space-time, encouraging expansion rather than resisting it. The more space stretches, the more influence dark energy appears to exert. It's as if the universe accelerates into an unknown it refuses to define for us. The effect brings to mind a trail disappearing into fog. The path continues, but the landscape ahead remains unseen. Mystery, in this sense, becomes a natural feature of cosmic growth. Another striking aspect of dark energy is its uniformity. No matter where astronomers measure, the influence is the same. It doesn't cluster or weaken. It doesn't fade with distance. This consistency hints at a mechanism not bound to any particular region. If a boundary existed nearby, dark energy would likely behave differently near that threshold. Instead, it feels endless in reach. Experiments using type Ia supernovae, baryon acoustic oscillations, and gravitational lensing all converge on the same result. The expansion accelerates smoothly. No anomalies appear to suggest a cosmic wall, edge, or transition. The acceleration doesn't stumble, it glides, as if the universe is expanding along a surface with no abrupt features. The phenomenon resembles a tide rising gently across a shore, steady, predictable, revealing nothing about where the ocean ends. Dark energy therefore hints at a cosmos that continues far beyond sight. The next layer of strangeness emerges when considering how the universe appears the same in all directions. Whether you look north, south, or toward the plane of the Milky Way, the large-scale structure remains consistent. This isotropy implies that no direction points toward anything like an edge. Everything stretches outward evenly, obeying patterns that seem to care little for orientation. Cosmic isotropy is confirmed by measurements of the microwave background, which reveals the same average temperature wherever we look. Small fluctuations exist, but they don't align or form gradients that suggest a boundary. The universe does not thin out in any specific direction. Instead, it presents itself like a sphere of consistent complexity. The view feels like standing in a field at night, where the horizon wraps around without variation. No corner appears, no edge invites attention. Symmetry whispers that vastness continues in every direction equally. Another mystery arises from the deep past. When we observe the cosmic microwave background, we find that regions far apart in the sky share nearly identical conditions, even though they should never have communicated with one another under normal expansion. This horizon problem suggests something extraordinary happened early on, something that connected the universe before separating it. Inflation solves this puzzle by proposing a burst of rapid expansion that stretched tiny uniform regions across enormous distances. If inflation occurred, then the part of the universe we see might represent only a microscopic portion of the full structure. Space could extend trillions of times farther than the region illuminated by ancient light. This makes the universe feel like a tapestry whose remaining threads vanish into the darkness, impossible to trace but undeniably present. The implication is simple. The unknown outweighs the known by an unimaginable margin. Even the shadows in the cosmic web carry clues. Observations show that matter organizes itself in enormous filaments surrounding vast voids. Yet these voids are not empty. They contain matter too diffuse to ignite stars. They stretch across hundreds of millions of light years, forming structures so large they defy easy comprehension. But these structures repeat across the sky, mirroring one another without suggesting an outer boundary. Large surveys reveal that the web doesn't stop abruptly. Instead, patterns fade gradually as distance increases. Galaxies dim, but the underlying structure persists. If a boundary existed, we might expect a sudden contrast, a thinning, a change in symmetry, or some visible deviation. Instead, The cosmic web behaves like a fractal that extends beyond the edge of the picture frame. It feels like wandering through a forest where every clearing leads to another, each wide and quiet, yet none announcing the end of the woods. Continuity replaces certainty. Dark matter deepens the enigma further. Although invisible, it sculpts the universe on massive scales. Its presence ensures the cohesion of galaxies and clusters, yet its distribution doesn't point toward any edge or transition. It spreads throughout space in patterns consistent with long-range structure. Even in voids, dark matter lingers softly, shaping regions where visible matter is scarce. Measurements of gravitational lensing reveal that dark matter halos extend smoothly, merging and stretching beyond observational limits. No abrupt decrease appears. No perimeter interrupts the continuity. Instead, dark matter behaves as though the universe has no outer shell at all, just interconnected fields, slowly weakening with distance but never vanishing entirely. Its behavior evokes the faint scent of rain carried on a long wind, dispersed, gentle but pervasive. Mystery, here, feels less like a puzzle and more like a landscape with endless horizons. Time itself contributes another layer of reverence. The universe has not always appeared as it does now, and it will not remain this way. As expansion accelerates, distant galaxies slip permanently out of reach. Regions that once shed light will become invisible. In the far future, the night sky may reveal only the galaxies gravitationally bound to our own local group. This fading visibility means the universe hides more of itself each passing epoch. Not because it ends, but because expansion draws curtains that time cannot lift. What lies beyond those curtains remains part of the same cosmic whole, but its light will never arrive. The idea resembles torches drifting away into the night, their glow diminishing, not because they extinguished, but because distance silenced them. Such quiet losses shape the way we think about endings. Even the concept of empty space becomes mysterious at large scales. Quantum fluctuations ripple through the vacuum, producing fleeting particles that appear and vanish instantly. These fluctuations occur evenly throughout space, suggesting a smoothness incompatible with abrupt boundaries. A genuine edge would break the symmetry that governs these fields. Quantum field theory predicts that vacuum energy permeates everything. If space ended sharply, energy would behave differently near the boundary, a signature we could detect. Instead, observations show consistency everywhere, from the deepest voids to regions surrounding galaxy clusters. It resembles a soft hum underlying a piece of music, consistent, subtle, uninterrupted. Continuity hints at infinity more convincingly than any grand announcement. The deeper one explores these phenomena, the more the universe begins to feel like an ocean whose depth exceeds every tool built to measure it. Not chaotic, not opaque, simply vast beyond practical limits. The pathways through which light and matter travel stretch farther than observation can follow. The laws remain consistent, but their stage expands beyond comprehension. Each discovery adds detail but also increases the sense of scale. Floating among these revelations, the idea of a cosmic boundary becomes increasingly difficult to reconcile with the data. Space unfolds like a symphony that never plays the final note, always extending the melody into new territory. It's like hearing music drift from another room, close enough to sense its beauty, too distant to ever hear the end. And as the melody continues, you begin to feel that endings belong more to perception than to the universe itself. A sense of quiet strangeness emerges when you realize that even the most advanced theories struggle to describe the universe's full structure. Each model captures a fragment of truth, yet none offer a complete map. The cosmos doesn't resist explanation out of hostility. It simply stretches into domains where human intuition loses its footing. Understanding becomes less about certainty and more about humility. One of the most intriguing suggestions comes from the possibility that the universe's geometry isn't uniform everywhere. While observations indicate a broadly flat cosmos, subtle variations could exist beyond our cosmic horizon. These variations might influence the destiny of distant regions, shaping expansion in ways we cannot detect. Some areas could stretch endlessly, while others might curve gently into forms we would never experience. This idea evokes the sight of a vast desert where dunes shift shape beyond the visible horizon. Patterns continue, but their details drift out of reach. Complexity doesn't require chaos. It often grows from simple rules applied across immense scales. Another veil of mystery appears when considering cosmic inflation in more detail. If inflation occurred, it may not have happened uniformly. Some regions could have inflated more rapidly, producing pockets of space-time with vastly different properties. These pockets would drift apart forever, each becoming its own cosmic domain, separated by expansion faster than light. In this picture, the observable universe becomes only one patch within a far larger structure. We don't see the transitions between patches because the boundaries expand too quickly to allow interaction. These boundaries aren't edges in the physical sense. They're regions where causality ends, where no signal can cross, where light forever fails to bridge the gap between domains. It resembles wandering through a forest and sensing distant valleys you'll never reach, not because they're forbidden, but because the trails dissolve before you arrive. The universe may contain many such unreachable valleys. Another possibility comes from the idea of false vacuum decay. Some theories propose that the universe might sit in a metastable energy state, not the lowest possible, but temporarily stable. If a transition to a lower state occurred, it would release a wave of energy reshaping space-time at the speed of light. Such an event would redefine what space even means, transforming the geometry entirely. Physicists debate the likelihood of such transitions. Most evidence suggests extremely long timescales, far beyond the life of stars. Yet the concept introduces a fascinating twist. Even if space seems infinite in extent, its stability might not be eternal. Structure could change abruptly at unimaginable distances or after unimaginable durations. The concept feels like discovering that the ground beneath an ocean has layers unseen, each capable of altering the tides above. Not all boundaries are spatial. Some are woven into the fabric of potential. The nature of dark matter adds another layer of strangeness. Although invisible, it shapes the cosmos more profoundly than ordinary matter. Its distribution forms a vast, interconnected skeleton guiding galactic formation. Yet nothing suggests that dark matter stops at a boundary. Models indicate its presence continues smoothly, thinning with distance but never terminating abruptly. Weak gravitational lensing maps show dark matter, halos blending into one another across enormous scales. No sharp transitions appear. Structures simply fade into broader frameworks, like ink dispersing in water. If the universe had an edge, we might expect dark matter to behave differently near that threshold, accumulating, thinning unnaturally, or curving in anomalous ways. But the data reveal no such signatures, only continuity. The effect resembles a fog bank that extends indefinitely, changing density, shifting subtly, but offering no glimpse of an end. Even more enigmatic is the idea that the cosmos may possess higher dimensional shapes we cannot perceive directly. In certain models, space-time behaves like a membrane embedded in a larger dimensional arena. Our universe could be one such membrane, with other membranes drifting nearby, each containing their own forms of matter and physical laws. These extra dimensions remain hidden because they may be compactified or accessible only through gravity. which interacts more subtly than other forces. Experiments have searched for deviations in gravitational behavior at short distances, potential indicators of hidden dimensions, but results remain consistent with four-dimensional spacetime. The notion suggests a painting with layers beneath the surface, visible strokes revealing only a fraction of the full composition. Depth can exist even when the eye perceives only the topmost layer. Another point of intrigue arises when examining how large-scale structures evolve over time. Early in the universe, matter clumped rapidly under gravity, forming dense knots and filaments. Over billions of years, these formations stretched and lengthened as expansion pulled distant regions apart. Yet even as structures separate, they maintain coherence, growing like cosmic vines, winding through an ever-expanding trellis. Simulations such as Illustris and Millennium track this evolution in remarkable detail. They reveal that the cosmic web persists regardless of scale. The pattern repeats with subtle variation, never collapsing into uniform emptiness, never condensing into fully bound regions. Instead, the universe balances density and expansion in a delicate interplay. The structure resembles frost forming on glass, branching, intricate, beautiful, yet dictated by invisible forces. Patterns repeat, but never identically. Time deepens the mystery further. Regions that once shared causal contact eventually drift beyond any chance of communication. The light they emitted long ago may reach us now, but their present state remains forever unknown. They continue to evolve, but their histories diverge from ours in ways that will never be observed. This separation highlights the idea that distance in cosmology isn't purely spatial, it's temporal. Two regions can be close in distance, yet forever separated in influence because expansion has outpaced the ability of light to connect them. From their perspective, we too fade beyond reach, becoming part of a horizon they cannot cross. It's akin to watching two boats on a fast-moving river drift toward different bends, close for a time, then irreversibly parted by currents neither can resist. The universe writes countless stories that never reunite. Even black holes hint at deeper truths. Their event horizons mark boundaries of no return, yet the space-time surrounding them obeys the same physical laws as the rest of the universe. Their presence demonstrates how geometry can impose limits without creating edges. A horizon is not a wall, it is a region where paths diverge, where future possibilities fork irreversibly. In some models, black holes may even connect to other regions of spacetime. While such connections remain speculative, they illustrate how boundaries can behave in unconventional ways, not as endings, but as thresholds. The structure of spacetime near such horizons hints at behaviors that could exist on cosmic scales, far beyond our observable sphere. Their nature evokes hidden chambers in ancient ruins, sealed, silent, but part of the same grand structure. Mystery often resides in transitions, not terminations. Quantum mechanics deepens the puzzle further. At the smallest scales, uncertainty dominates. Particles flicker in and out of existence. Positions and energies fluctuate unpredictably. This randomness is fundamental, not a result of measurement limitations. If space were to end abruptly, quantum rules would need to change near that boundary, leaving detectable anomalies. Yet experiments reveal uniform quantum behavior everywhere we look, in vast intergalactic voids, in dense clusters, in laboratories on Earth. The consistency of quantum fluctuations suggests no underlying edge shapes their expression. Instead, their randomness spans the cosmos like a faint, ever-present whisper. The behavior resembles wind moving through tall grass, chaotic in detail, uniform in presence. Continuity often hides within unpredictability. Taken together, these clues paint a universe that behaves like an unbroken expanse. No observation has revealed a hint of abruptness. No measurement has uncovered a transitional zone. Everything, from matter distribution to vacuum fluctuations, points towards smooth continuation. The mystery lies not in where space ends, but in why it feels so boundless, so calm, so committed to uniformity across immense distances. And this is where reverence emerges, not from fear of the unknown, but from acknowledgement of its immensity. The universe doesn't refuse to be mapped. It simply stretches beyond the reach of any map a finite species could draw. Mystery becomes a companion rather than an obstacle. It's like standing in a cathedral built of starlight, knowing the walls extend far beyond the glow of your lantern. And somewhere in that silent immensity, the question lingers: how far can existence truly unfold? Curiosity shifts its tone when you begin to sense that the universe might not be built for clarity. Some truths feel deliberately softened, as if space were wrapped in layers meant to be approached gently. The more we uncover, the more the cosmos reveals its preference for subtlety over spectacle. It's vast not only in distance, but in quietness, a quietness that invites slow thought. One avenue into this silence comes from studying large-scale motions of galaxies. Beyond expansion, some galaxies drift in coordinated directions, forming what researchers call bulk flows. These flows hint at gravitational influences lying far outside the observable region. Something massive, unseen and distant may be tugging on entire clusters, gently but consistently. The motion feels like the pull of a distant tide, invisible in origin, unmistakable in effect. Hints of the unseen are often more telling than direct observations. A particularly enigmatic example is the so-called dark flow, where hundreds of galaxy clusters seem to move toward a region beyond our perceptual boundary. This motion challenges simple models of cosmic uniformity and raises the possibility that structures larger than the observable universe might exist. If such structures are real, then our cosmic neighborhood is merely a quiet inlet beside a vast ocean. These flows don't break the laws of physics. Instead, they reveal just how limited our field of view truly is. Light from the regions influencing these motions will never reach us because expansion outruns the journey. Yet their gravitational whispers leak inward, carrying fragments of an unseen architecture. The concept resembles feeling a subtle vibration through the floorboards, something stirring beneath out of sight. Distance, in this context, becomes a form of hidden presence. Another puzzle emerges from the cosmic microwave background itself. While mostly uniform, it contains anomalies, a cold spot larger than expected, hemispheric asymmetries, faint directional imbalances. None are definitive, yet each suggests a possibility that the universe may possess structure beyond the simplicity of perfect uniformity. Scientists debate whether these anomalies result from statistical flukes, foreground interference, or deeper cosmic features. If the latter is true, the observable universe might be a small patch with unique traits, shaped by regions lying beyond reach. Our cosmic bubble, then, would not be representative of the whole, only one chapter in a longer, largely unread book. These subtle distortions feel like faint brushstrokes on an ancient fresco, hints of a larger image that time has partially obscured. The art exists. We simply see only part of the wall. Even the darkness between galaxies holds layers of intrigue. Within those regions, background radiation, gravitational influences, and subtle quantum fields mingle in ways that imply continuity far past observational limits. If an edge existed, these interactions would show signs of disruption. Patterns would break, gradients would shift, fields would weaken abruptly. Yet every measurement reveals smoothness. The vacuum behaves consistently across staggering expanses. Light bends predictably. Quantum fluctuations remain uniform. It's as though space refuses to reveal any hint of discontinuity. This unwavering regularity feels almost intentional, not in a purposeful sense, but in a structural one. The universe seems designed to avoid abruptness. It recalls the way a coastline curves gently, rather than ending in a straight, artificial line. Nature rarely chooses sharp endings. Another layer of strangeness appears when considering the growth of entropy. As the universe expands, entropy increases, pushing the cosmos toward a colder, more diffuse state. This gradual cooling suggests an infinite or near-infinite landscape in which entropy can continue rising indefinitely. A finite universe without boundaries could reach equilibrium quickly. Yet ours continues changing with remarkable steadiness. Black holes represent the universe's greatest repositories of entropy. Their behavior, thermodynamics, and eventual evaporation suggest long-term processes operating over timescales so immense that endings lose conventional meaning. The universe evolves towards states we can describe mathematically, but can hardly picture intuitively. These processes feel like embers smoldering for ages, slow, quiet, but persistent. Longevity becomes a form of mystery in itself. When astronomers study the distribution of supervoids, immense, sparsely populated regions, a subtle pattern emerges. These regions are not random gaps. They appear in consistent proportions across large surveys, suggesting an underlying harmony in how matter and emptiness coexist. This harmony persists no matter how far we look. If space had a boundary, the distribution of voids might skew near that region. Instead, voids behave as though they belong to a repeating, continuous pattern. Their presence supports the idea of a cosmos that expands gently without interruption, weaving density and emptiness together into a balanced whole. These voids resemble pauses in a long piece of music, silent measures that give shape to the surrounding sound. Silence, too, can reveal intention. Another enigmatic clue comes from baryon acoustic oscillations, ancient sound waves frozen into the distribution of galaxies. Their wavelengths offer a kind of cosmic ruler. By comparing the scale at different distances, scientists track how the universe expanded over time. The results show smooth and continuous growth without deviations that a boundary or discontinuity might cause. If space had finite limits or abrupt transitions, these oscillations could appear distorted or compressed in certain directions, yet the pattern remains strikingly consistent, even in the deepest surveys. The universe expands like a fabric woven evenly in every direction, with no tugging or fraying at its edges. The effect resembles watching a flag rippling in steady wind, fluid, rhythmic, without abrupt stops. Continuity seems to be the cosmos's preferred language. A deeper mystery arises when exploring the mathematics of spacetime. Some solutions to Einstein's equations describe universes with no boundary, looping subtly or stretching indefinitely. Others allow for complex shapes impossible to visualize. Our universe might follow one of these exotic geometries. If so, edges might be illusions born from perspective rather than features of reality. Because general relativity permits many cosmic shapes, only observation can narrow the possibilities. Yet our observational bubble is too small compared to the whole. We could inhabit a region that appears flat, while the larger universe folds in ways we cannot detect. Local measurement doesn't guarantee global truth. The situation mirrors standing on a wide, featureless plateau. The land feels flat, but the world may curve gently far beyond sight. Perspective shapes interpretation more than measurements do. Quantum cosmology pushes the mystery even further. Some models propose that space emerged from fluctuations in a primordial quantum state. If so, the universe may be part of a broader ensemble of possible configurations. Boundaries could exist in abstract spaces, not physical ones. What we perceive as a universe might be a single solution among countless others, each with its own shape and duration. Such models challenge the distinction between infinite and finite. A universe can be finite yet unbounded, limited yet endless in traversal, contained yet lacking walls. These paradoxes highlight how human language struggles to describe shapes we cannot visualize. It feels like trying to describe a color invisible to the human eye, real, present, but beyond articulation. Mystery arises not from complexity, but from unfamiliarity. As we explore these ideas, a soft reverence begins to form, the kind that grows when knowledge meets humility. We recognize that the universe reveals only the part our light cone intersects. Everything else remains in quiet darkness, continuing its own evolution, unaware of our attempts to understand it. The cosmos holds more pathways than we will ever trace, more distances than light can travel, more shapes than geometry can describe. We stand in a small clearing illuminated by ancient photons, surrounded by a forest whose depth escapes us. It's like hearing a faint melody drifting from far away, familiar enough to stir emotion, too distant to decipher completely. And in that quiet distance, the universe feels both intimate and incomprehensibly vast. A strange quietness settles in once you realize how little of the universe we will ever witness. Not because we lack curiosity or tools or time, but because the cosmos itself withholds most of its story behind horizons we cannot cross. This awareness doesn't bring fear, it brings a soft ache, as though the night sky were sharing a truth meant to be felt rather than solved. If you trace the universe's history backward, the timeline narrows quickly. Stars ignite late, galaxies assemble slowly. Life, at least in our form, appears almost at the end of a cosmic symphony already trillions of measures long. Human presence, brief and delicate, occupies only the final whisper of an ancient song. Our questions echo through halls that existed long before we arrived. Contemplating this scale feels like holding a fading photograph, something precious but dwarfed by the time surrounding it. Fragility and wonder often walk hand in hand. The idea that we may never reach the universe's limits becomes even more tender when you consider how finite our own experiences are. We live in bodies with expiration dates, on a planet with a temporary window of habitability, orbiting a star that will one day dim and cool. Yet each of us carries within ourselves atoms older than Earth itself, forged in stars that no longer shine. Those ancient elements traveled through countless processes, fusion, supernovae, interstellar drift, before finding their way into you. The calcium in your bones, the carbon in your muscles, the iron in your blood, all were shaped by forces working long before your lineage began. This lineage connects you backward into cosmic history so deep that it feels almost mythic. It's a quiet reminder that even brief lives can hold ancient origins, and in that connection, loneliness begins to soften. Even the night sky participates in this gentle melancholy. The stars you see are not showing their present selves. Their light is a relic, a time capsule crossing space to reach your eyes. Some may have already collapsed or transformed into something new. The sky above you is a museum of past brightness, a gallery curated by distance and time rather than intention. Astronomers rely on this delayed light to study cosmic evolution. Every glance upward becomes an act of looking backward, reaching through eras you will never experience directly. Each photon carries a story older than languages, cultures, and continents. You stand beneath a vault of memories, not moments. It feels like listening to a voice recorded by someone who's long gone, still vivid, still present, but separated by the quiet boundary of time. Beauty intensifies when framed by absence. The further we peer into the cosmos, the more it resembles a place composed of goodbyes. Galaxies drift apart, and their light eventually fades from view. Expansion ensures that most of the universe will never be known to us. Even within our local cosmic neighborhood, stars burn out, planets cool, and systems dissolve. Change is constant, and permanence becomes the rarest phenomenon of all. Nevertheless, the laws that govern these changes remain consistent. Gravity, thermodynamics, quantum behavior. They weave the universe together with a set of rules that never falter. Even in decay, there is order. Even in endings, there is structure. This stability offers comfort. The cosmos may not last forever, but it evolves with grace rather than chaos. Such evolution resembles the slow turning of seasons, inevitable, steady, and strangely calming. Transience becomes part of the universe's poetry. If you shift focus toward the distant future, a melancholic truth emerges. Expansion will one day carry most galaxies so far away that their light will never reach us. The night sky will grow emptier. Future beings, should they exist, might live under a sky devoid of distant galaxies, unaware that the universe was once full of light. Their cosmos will feel smaller, quieter. This isn't a prediction of doom, but of solitude. Space gradually withdraws its brightness, not out of malice, but because its own momentum leads it toward colder, quieter epochs. The beauty we see today is temporary, a momentary glow in a cosmic lifespan that stretches beyond even imagination. The thought resembles watching the embers of a fire slowly fade, warm for a moment, then drifting into darkness. Awareness of impermanence intensifies appreciation. In the long run, even stars cease to shine. After trillions of years, the universe enters an era where black dwarfs, neutron stars, and faint remnants dominate. Light becomes rare, heat dissipates, motion slows as gravity releases its grip on distant structures. If space extends indefinitely, its future resembles a quiet sea without waves, vast, cold, and nearly still. Despite this, the universe never becomes empty. Particles linger. Quantum fluctuations persist. Faint traces of former brilliance continue drifting through the void. Nothing fully vanishes. It merely transforms. In this distant era, the cosmos won't be dead, just resting, humming softly in a different register. It's like hearing the final notes of a lullaby continue resonating long after the music stops. Silence can carry memory if you listen closely. When reflecting on these distant times, a tender realization emerges. We are alive at a moment when the universe is rich in light, active in formation, abundant in warmth. We inhabit a cosmic springtime, brief compared to the aeons ahead. Galaxies still collide, stars still blaze, the night sky still sparkles with the relics of earlier creation. This era is rare, a fleeting chapter when conditions allow complexity to thrive. Life, intelligence, curiosity. All of these may be temporary phenomena made possible by a narrow window in cosmic evolution. You exist within that window, conscious of your place in a story far bigger than your lifespan. The awareness feels like standing beneath cherry blossoms during their short bloom. Delicate, fleeting, unforgettable. Ephemerality becomes a form of grace. The universe, in all its enormity, still shapes inner landscapes. The more you contemplate its possible infinity, the more you sense the contrast between our short human arcs and cosmic endurance. Yet this contrast doesn't diminish us. If anything, it enhances the meaning of being briefly aware in such a vast system. To understand even a fraction of reality is an extraordinary privilege. Astronomy doesn't offer comfort by shrinking the universe. It offers comfort by inviting you into its immensity. You are small, yes, but made of the same materials that glow, collapse, fuse, and dance across billions of light years. Your existence is improbable, but deeply connected to everything else that exists. It feels like recognizing your reflection in a pool that reflects not just you, but the sky above. Belonging emerges from perspective. The deeper you drift into these thoughts, the more the question, does space end, becomes symbolic. It's not just a question about boundaries, it's a question about our longing for orientation in a realm without edges. Humans search for edges instinctively, in maps, in lifespans, in narratives. The universe answers with openness instead, inviting acceptance rather than closure. This openness encourages a shift in perspective. Instead of seeking where space stops, you begin to wonder how far understanding can reach, how deeply curiosity can extend, how softly knowledge can settle in the mind without needing complete resolution. Infinity stops being frightening, it becomes spacious. It resembles walking into a library with no final shelf, endless, quiet, welcoming. And somewhere in that quiet, you begin to feel at home. A quiet turning happens when you finally accept that some answers will never be found. Not because humans lack intelligence, but because the universe operates on scales beyond our reach. The longing to understand doesn't fade, it simply softens, settling into a calm appreciation for mystery. In that acceptance, something surprising appears. Peace. A peace born not from certainty, but from surrender. When you study the expansion of space, a realization emerges that every second increases the distance between distant galaxies. Some recede so quickly that their light will never reach us, no matter how long we wait. This expansion creates a cosmic loneliness, not in an emotional sense, but in a structural one. Vast regions drift forever out of view, leaving the observable universe as a shrinking island of visibility. The image resembles watching lanterns float across a dark lake, each drifting farther until their glow finally disappears. Separation can be quiet but never empty. Even within our galaxy, change never ceases. Stars orbit the center like slow-moving dancers, each on its own elongated path. Over millions of years, constellations rearrange themselves, dissolving into new shapes. The sky familiar to us today would be unrecognizable to distant descendants. Time redraws the heavens with gentle, persistent strokes. This dynamic sky illustrates a truth often forgotten. Permanence is an illusion. Even the night, in which feels eternal to the naked eye, evolves silently. Every star you see is in motion, migrating through gravitational tides. The constellations are temporary patterns, meaningful only because your lifetime is so brief. Their shifting resembles handwriting erased and rewritten over centuries, always similar, never identical. Memory forms bridges where permanence cannot. This realization deepens when you consider how short a window of time allows life to exist here at all. Before Earth cooled enough to host oceans, the universe had already expanded for billions of years. After several more billions, our sun will swell and consume the inner planets. Life on Earth occupies only a narrow sliver of the cosmic timeline, a fragile flame flickering in a vast night. Yet within that flame, consciousness emerged. The ability to ask questions like, "Does space end?" is a marvel by itself. The atoms that form your thoughts once drifted through nebulae, cooled in interstellar clouds, and gathered within ancient stars. Their journey spans epochs far beyond imagination. Awareness is the universe briefly recognizing itself through you. It feels like waking from a dream and realizing the dream already existed long before you opened your eyes. Awareness becomes a continuation, not a beginning. The deeper you reflect, the more the cosmos begins to feel like a place shaped not just by distances, but by absences. Empty regions dominate. Light becomes scarce. Gravity stretches matter thin. Space is mostly silence, interrupted occasionally by the bright noise of galaxies. These luminous islands stand out because darkness is their canvas, not their opposite. Astronomers sometimes describe voids as being full of nothing, but even this nothingness has structure: quantum fields, faint particles, thin traces of radiation. It is emptiness only by human standards. By cosmic standards, it is simply another form of existence. The feeling resembles standing in a deep fog, seemingly empty, yet filled with texture once you pay attention. Emptiness isn't absence, it's subtlety. The far future of the universe hints at a melancholy that doesn't frighten. As expansion accelerates, galaxies drift beyond visibility, and the night sky grows increasingly sparse. Stars burn out. Materials become scarce. The vibrant era we inhabit comes to an end, replaced by a quieter epoch where remnants float through a cold, thinning sea. Even then, the universe doesn't vanish. It simply transitions into a new form, a different chapter written in a slower tempo. Processes continue, though faintly. Gravity still shapes motion. Quantum fluctuations still whisper through the vacuum. The cosmos keeps evolving long after its brightest days fade. It's the kind of silence you hear at the end of a long symphony, full, resonant, still alive. Endings, when stretched across eternity, become transformations. Contemplating this fate encourages a sense of intimacy with the present universe. You exist in a moment when the cosmos is vibrant, illuminated by countless stars, rich in energy. This era is not typical, it's fleeting. You are alive during a cosmic spring when galaxies still bloom, nebulae still glow, and the night sky still remembers its beginnings. That awareness can make even an ordinary glance at the stars feel monumental. You are witnessing a phase the universe will not experience forever. Future epochs will be far quieter, far darker. Yet you exist now, in the slice of time where brilliance flourishes. It's like standing by a river in mid-sunrise, colors vivid, reflections bright. Knowing the light will eventually soften, appreciation deepens when framed by rarity. Another layer of introspection appears when you consider how the universe looks from viewpoints other than your own. To a photon traveling near light speed, time barely passes. To a particle in deep space, gravity feels almost non-existent. To a supermassive black hole, spacetime curves so intensely that distance and duration intertwine. Each perspective reveals a different version of reality. Humans inhabit only one narrow perception of the cosmos. We interpret everything through senses tuned for survival on a small rocky planet. Yet despite this limitation, we try to understand structures billions of light years across. That ambition, humble yet enormous, speaks to something deeply human, a longing to know, even without the promise of answers. The feeling resembles trying to read an ancient manuscript with half the letters missing. Knowledge grows from curiosity, not completion. All these reflections bring us back to the central question. If space has no edge, what does that mean for us? Perhaps it means the universe doesn't operate in terms of boundaries at all. Instead of borders, it offers gradients. Instead of endings, transitions. Instead of limits, horizons. Human minds crave edges because edges feel certain. The cosmos responds with openness, inviting exploration without guaranteeing closure. This openness isn't cold, it's spacious. It makes room for wonder, for creativity, for meaning that isn't tied to finality. You don't need to reach the end of space to belong within it. Belonging comes simply from existing as a part of it, a small part, yes, but an authentic one. It's like living beside an endless ocean. You will never see the far shore, but you are still shaped by the tides. Meaning doesn't require full comprehension, and so, when you gaze into the night sky and feel that tender ache, that mix of awe, insignificance, beauty, and longing. You are experiencing something profoundly human. You're recognizing your brief presence in a universe that stretches far beyond you, yet still includes you. Your awareness, however small, becomes a thread in the fabric of cosmic history. The universe may not offer answers to all questions, but it offers perspective. And within that perspective lies a gentle truth. You do not need to grasp the entirety of existence to feel connected to it. Simply standing beneath the sky is enough. It feels like resting your hand on ancient stone, solid, quiet, enduring, patient, and in that contact, the infinite feels just a little closer. A gentle acceptance begins to take shape when you stop trying to force an answer to the question of whether space ends. The tension dissolves, replaced by something softer, a sense that the universe doesn't need to be fully mapped for you to exist meaningfully within it. The unknown becomes a companion rather than an adversary. It's a shift from grasping to resting. Modern cosmology hints that expansion will continue indefinitely. As distant galaxies drift beyond observable range, our corner of the universe becomes increasingly self-contained. This isn't isolation, it's evolution. The cosmic landscape changes slowly, like light fading during twilight. What remains is a quieter sky, still governed by the same laws, still unfolding according to patterns laid out billions of years ago. The transition is similar to watching the tide recede, gentle, inevitable, never abrupt. Change often speaks in whispers, not declarations. When you contemplate this distant future, a surprising warmth arises. The universe doesn't abandon complexity, it preserves it in subtler ways. Stars fade, but remnants persist. Motion slows, yet never fully stops. Entropy increases, but quiet forms of structure continue drifting across the deep. Even when the cosmos grows dim, it retains traces of every bright moment that came before. These traces serve as cosmic memory, not in a conscious sense, but in a physical one. Patterns of energy and matter hold imprints of their origins. Galaxies, nebulae, even empty regions still carry signatures of past interactions. The universe remembers not through intention, but through structure. This memory resembles footprints in wet sand, fading slowly, but unmistakably connected to what passed. Presence lingers long after motion calms. One of the most comforting ideas in astrophysics is that the universe is self-consistent. The same principles apply everywhere, from the densest cluster to the emptiest void. No region cheats the rules. That unity creates a sense of belonging. The atoms in your body obey the same laws that shape galaxies. You are stitched into the universe by the same physics that guides starlight. The cosmic order doesn't require your awareness, yet it includes you effortlessly. You're not an intruder wandering through a structure built for something else. You're part of the geometry, part of the timeline, part of the unfolding pattern. Your existence is an expression of the same rules that govern distant quasars and slow-moving dust. It's like realizing the melody you hum fits naturally into a song you never knew you were part of. Harmony emerges without asking permission. The more you embrace this perspective, the more peaceful the infinite becomes. Infinity stops being an intimidating abyss and starts becoming a spacious backdrop, a canvas that leaves room for curiosity, reflection, and meaning. If the universe had edges, perhaps we would fixate on reaching them. Without edges, we are freed from that chase, allowed to explore inward instead of outward. This inward exploration reveals something profound. The cosmos feels infinite, not only because of its size, but because of what it evokes. It invites thoughts that expand, not contract. It encourages questions rather than conclusions. It offers horizons instead of walls. In this sense, infinity becomes less about measurement and more about openness. It resembles walking through a quiet valley with no visible boundaries, free to wander, free to pause. Space feels generous when it stops insisting on answers. Astronomers often talk about cosmic horizons, the limits of what can be observed. Beyond those horizons, regions continue evolving, forming stars, collapsing matter, and drifting through time. These regions exist regardless of our ability to see them. The universe does not depend on our gaze to unfold. That independence can feel humbling at first, but eventually it becomes comforting. It's reassuring to know existence doesn't require observation to be valid. Reality persists whether or not anyone is looking. This means the universe is stable, resilient, self-sustaining. Humans witness only a fraction, but that fraction is enough to cultivate wonder. You don't need to touch every part of the ocean to feel its depth. The thought resembles listening to rain in another room, out of sight, but real. Quietness doesn't diminish presence. As you drift through these reflections, the question, does space end, becomes less literal. It turns into a symbol of human longing for closure, for certainty, for boundaries. But boundaries are often artificial comforts. The universe offers something subtler and more profound: continuity. That continuity doesn't give you edges to hold, but it gives you a place within the flow. Embracing continuity teaches a different kind of clarity, one grounded in acceptance rather than conclusion. The cosmos doesn't have to answer your questions directly for you to feel oriented within it. Your sense of direction can come from participation, not from certainty. It's similar to traveling a winding path at dusk. You don't see the end, but the journey feels meaningful anyway. Direction can emerge without a destination. Another serene realization arises when you consider how much of the universe's beauty depends on limits. Stars shine because nuclear fuel is finite. Galaxies glow because their lifespans are temporary. Light reaches your eyes precisely because it travels at a fixed speed, never instant. Even the expansion rate shapes the cosmic web into its delicate structure. If everything were eternal and unchanging, the night sky would be featureless. The universe's impermanence is what makes it breathtaking. Each moment holds a unique configuration of matter and light that will never occur again. You are witnessing an arrangement shaped by countless fragile contingencies. It feels like watching frost crystals form on a window. Delicate, temporary, dazzling. Transience enhances beauty rather than diminishing it. The deeper you go into these thoughts, the more a sense of companionship arises. The universe isn't a cold or empty void. It's a vast stage where processes unfold in harmonious patterns. Galaxies orbit, stars pulse, atoms vibrate. Everything participates in a cosmic rhythm, whether fast or slow, bright or subtle. And you, simply by existing, keep time with that rhythm. This companionship isn't about connection in a personal sense. It's about alignment. You move through space not separately, but as part of its continuous fabric. Your heartbeat, your breath, your thoughts, all are made possible by physical laws that run through every corner of the cosmos. The feeling resembles drifting in a warm current, carried, supported, included. Belonging doesn't need language to be understood. As these realizations settle, a calm trust begins to form. You no longer need space to end for the universe to feel complete. Infinity doesn't take anything away from you. It simply offers more room for thought, more room for existence, more room for quiet. The unknown becomes spacious rather than intimidating, open rather than overwhelming. You start to sense that answers aren't the goal. Presence is, and presence requires only awareness, not certainty. You can rest within a cosmos that continues far beyond your understanding. You can find peace in the very fact that not everything needs to be grasped. It's like standing beneath a clear night sky and realizing that silence is an answer too. The universe speaks softly when you stop trying to force its voice. In this softened state, the final question becomes simple. If space truly has no end, how do you live within something so unbounded? The answer arrives quietly. You live the same way you always have. By noticing, by wondering, by breathing, by participating in a universe that doesn't require you to master it. The infinite doesn't demand more from you than finitude ever did. And the more you accept that, the more the cosmos feels like a home without walls. Open, calm, and welcoming, it resembles lying back in a field beneath an endless sky. No edges, no urgency, just quiet presence. And in that stillness, the infinite becomes gentle. A gentle stillness settles in as you return from the vastness of these reflections. You've drifted through horizons that stretch beyond sight, wandered along the edges where light grows thin, and touched the soft uncertainty that surrounds all cosmic questions. And now, as you settle back into yourself, the infinite feels less like a distant abyss and more like a quiet companion. The universe no longer looms above you. It rests around you, patient and calm. Throughout this journey, you discovered that space doesn't need a boundary to feel meaningful. Its openness is not a flaw, but a feature, a vast canvas that invites curiosity rather than containment. The cosmos reveals itself slowly, offering fragments of insight without demanding that you solve its entirety. You're allowed to breathe within the mystery, to explore without expectation, to rest without reaching an end, and in that quiet permission, a sense of belonging grows. You are made of the same stars whose light softened the night sky billions of years ago. The atoms in your body traveled through ancient nebulae, survived stellar deaths, and drifted across unimaginable distances before settling into the person you are now. You carry pieces of cosmic history within you, not as decoration, but as identity. As you reflect on the immensity around you, something tender reveals itself. The infinite does not diminish your existence, it frames it. Your thoughts, your movements, your breath ripple through the same laws that guide galaxies. You are small, yes, but never insignificant. Scale does not dictate value. Even the faintest star contributes to the night. The universe's grandeur becomes even more beautiful when viewed through the lens of transience. Every star that shines, every galaxy that rotates, every tide of expansion that sweeps across the cosmos exists for a limited span of time. And yet, each moment, including this one, is complete in its own way. You don't need eternity to feel part of something vast. A single gaze at the sky is enough. Perhaps that is the quiet lesson hidden beneath the question of whether space ends. Not all mysteries require closure. Some are meant to accompany you, walking beside you gently, shifting as you grow. You can carry them like a soft lantern, illuminating not the entire path, but just enough for each step. If this quiet journey brought you even a moment of peace, or sparked a thought that helped you feel a little more at home in the universe, I'm genuinely grateful you chose to spend this time here. Before you drift into rest, feel free to share where you are tonight and what time it is. It's always comforting to know where in the world these reflections are reaching. And now, as the last echoes fade, let the night wrap softly around you. The stars continue their slow motions, galaxies continue their distant dance, and the universe remains wide open, not demanding answers, just offering presence. Your presence, your awareness, even your quiet breathing are part of that vastness. May the calm linger long after these words end, like a faint constellation glowing in the corners of your mind. And wherever you drift next, in thought, in sleep, in life, may you carry the gentle certainty that the universe holds room for you.